To study the power in an AC circuit, first we will discuss the power factor. Power factor, which is abbreviated as PF, is equal to cos phi. Here phi is the angle between applied voltage V and the current in the circuit I. If we consider series LCR circuit and draw the phase diagram, suppose this is the current, then voltage across the resistor will be in same phase, while the voltage across the inductor will be 90 degree ahead to the current. Also, voltage across capacitor will be 90 degree behind the current in phase. Therefore, net voltage, suppose VL is greater than VC, it will be VL minus VC. And if we have to find the net voltage applied, so we complete the diagram, and the diagonal of this rectangle will give the net voltage. And the angle between this net voltage V and the current is phi, and cos of this angle phi is called the phase angle. So we can write that cos phi is equal to, because cos from trigonometry is base oblique hypotenuse, so it is VR by V, and that is equal to, because current in the circuit is I and circuit being series circuit, current will be same in inductor, capacitor and resistor, so we can write this is I into R by I into, and because it is the net voltage applied, and this voltage will be equal to I into impedance of the circuit, so we can write it as R by Z. Hence cos phi is finally can be written as power factor, that is R by Z. It is a ratio of the resistance and the impedance. We can also find a term that is tan phi. This tan phi will be equal to the perpendicular by base, so it is VL minus VC divided by VR, or we can write it is IXL, where XL is the inductive reactance of the inductor, minus, because current is same being the series circuit, so it is I into XC. XC is the capacitive reactance of the capacitor divided by the I into R. So it will be equal to XL minus XC by R, where inductive reactance XL is omega L and capacitive reactance XC is 1 by omega C. Now to find the instantaneous power supplied by the source, we consider that instantaneous current is Im sin omega t and instantaneous voltage is Vm sin omega t plus phi, considering that voltage is ahead in phase to current by angle phi. So instantaneous power P will be equal to voltage into current, and substituting the value we will have Vm sin omega t plus phi into Im sin omega t. So this will be equal to Vm into Im and sin omega t plus phi into sin omega t. Now using the trigonometry, we will write it as Vm Im by 2, and we also multiply in numerator by 2, that is 2 sin omega t plus phi into sin omega t. Now using the trigonometrical relation, we can write that it is Vm Im by 2 into cos, and because it is 2 sin A sin B, so we apply the formula and we will get cos phi minus cos 2 omega t plus phi. We know the formula is cos C minus cos D equal to 2 sin C plus D by 2 sin D minus C by 2. So it will be equal to Vm by root 2 into Im by root 2 into cos phi minus cos 2 omega t plus phi. Vm by root 2 can be written as Vrms, or simply capital V, Vm by root 2 is root mean square value of the voltage. Similarly, Im peak value divided by root 2, it gives the RMS value of the current, and that can be simply written as capital I. So we write it is Vrms into Irms into cos phi minus cos 2 omega t plus phi. Now we take the average for a cycle because this is the instantaneous power. So if we consider one cycle and take the average, then average power for one cycle, it will be P, that is equal to Vrms into Irms. These are the constant term in respect of the cycle. This cos phi is a fixed angle, so it is also remains same minus. And because here variable is t, and cos 2 omega t plus phi will have a shape like this. This is a cos cycle starting from 0 to 2 pi. So in this, if we take the average, this will be 0. So this have the average value 0 for one cycle, so we write it is minus 0. Hence we can write that average power for a cycle is Vrms into Irms into cos phi, or in short we can write it is V equal to Vrms can be written as simply V, Irms can be written as simple I into cos phi. So average power in the AC circuit is depending on the voltage, current as well as the power factor, where cos phi is the power factor. This is the power factor. Because V is the voltage applied to the circuit, which is the series LCR circuit. So V, as we have already written that it is IZ, where Z is the impedance of the circuit. So we can write also it as I square Z into cos phi. Here Z is impedance of circuit, and its value is equal to root R square plus XL minus XC whole square. So we have found the average power in the circuit, that is product of voltage, current and cos phi. V is the RMS voltage, I is the RMS current and cos phi is the power factor, where power factor cos phi is the ratio of resistance and the impedance Z, and it can be written for LCR circuit as root R square plus XL minus XC whole square, where XL is the inductive reactance which is equal to omega L, and XC is the capacitive reactance which is equal to 1 by omega C. So we now discuss different cases. Suppose circuit is purely resistive. For purely resistive circuit, voltage and current are in phase. That means phase angle is 0, or this implies that power factor equal to cos phi will be equal to 1. Hence, P will be equal to Vi, and this will be the maximum power. So, power dissipated is maximum when the circuit contains purely resistor. Second case is the circuit contains purely the inductor or capacitor. In this case, the phase angle will be pi by 2 in case of pure inductor or pure capacitor. So this implies that power factor equal to cos phi will be equal to cos pi by 2 will be 0. Hence, power in the circuit will be 0. Therefore, in a circuit containing purely inductor or a purely capacitor, current though flow in the circuit, but there is no power dissipated. Hence, the current in such cases is called wattless current. Similarly, if we consider that LCR circuit is in resonance in LCR circuit. In resonance, inductive reactance will be equal to capacitive reactance, and this gives a frequency that is called resonant frequency, and it is equal to 1 by LC. This can be calculated using omega naught L will be equal to 1 by omega naught C. So this omega naught is the resonant frequency. If we put the value of XL equal to XC in the formula of power factor mentioned above, we will have cos phi will be equal to R by Z, that is equal to R by root R square plus 0, or it is equal to R by R, that is equal to 1. This implies that cos phi is equal to 1, means maximum. So power factor will be maximum, and in this case also there will be the maximum power dissipation through the resistor R. Similarly, if we consider inductor resistor or capacitor resistor or inductor capacitor resistor circuit not in resonance, here also power is dissipated only in the resistor. Phase angle is phi, then power factor cos phi will be equal to R by Z, or we can further write it as R by root R square plus XL minus XC whole square, where XL is equal to omega L, this is the inductive reactance, and XC is 1 by omega C, this is the capacitive reactance. So here cos phi lies between 0 to 1, and phi lie between the 0 to pi by 2. Let's take some examples.